Green light.
Is this chapter 4.5?
No, this is 4.5.
4.5.
Oh my god, I'm moving so much.
All right, so we'll see what happens if this comes online. I hope it does. I'll just get started. So we've already done these things, but we're going to talk about kind of like what you did, shifting the function, shifting it up, down, left, right, compression, all those other things that we've done before. So as we move on, I want to just remind you about some of those things that were available before. If we look at the function y equals sine, let's go with x. Cool? What am I talking about, sine x? Thinking. X squared. Everyone remember what type of function this is? Parabola, right? It's a shift in, it's a facing upward parabola, just positive, regular, nothing special about it, right? And there's a couple things that we could do with it. We could move it up or down, with what value? K. And K is out here by itself, correct? So it's kind of shifting the whole function. We also have the value of H. I should do a minus H because it's built in. Where H tells you the horizontal shift, and you got to be careful because of that negative. But notice that K is out here by itself, and it's manipulating this entire quantity, right? So all of this is just a number, and it would shift all of them up or down, depending if this is positive or if it's negative. So that's the idea behind it. I could also do a stretch compression, right? What value was that? That's an A value, okay? Now there's another thing that we could do. Well, actually, there's two more things. If I was positive and I wanted to flip it, Corbin, MJ, can you guys close your laptops, please? If I wanted to reflect it over the x-axis, what did I have to do? Make it a negative what? Make it negative A. So I could do a negative. That would be a reflection. I could also not just reflect it over the x-axis. I could reflect it over the y-axis. Anybody remember how to do that thing? We talked about it briefly. Yeah. There's going to be some value up front. We could just call that B if you wanted to, or negative B, but usually just a negative, right? If I make that, that would flip it. Okay? But we didn't really see a B value. Just like before, there was no, when we were doing lines, there really was no H value, was there? There was a K value only. But what did we call it back then with linear functions? We called it B. The only function that really lets you see all of it up to now is the square root function. It's a square root function. So if I did, I need to minimize. I know. I actually had real ramen for the first time, and it was so good. I think I did it justice and ate it like I'm supposed to. That's not where I want to go. What did this guy do to my computer? Did we do that? We played around with the square root and we made it flip and over and over and over? No? Do you remember that? No? I don't remember that. What are you talking about? Let's clear this. So here's what I want to show you first. Second square root x.
Oh, you heard that? Yeah.
So here's the square root of x. No surprise there, right? We talked about putting the A value and making it a negative value. So I can do negative square root of x. What's that supposed to do again?
Flip it over the x.
Flip it over the x-axis. So that's just a confirmation real quick. We're flipping it over the x-axis. There it is. If I go back here and I don't make it out on the outside, I put it on the inside. So if I did the square root of negative x, what's that supposed to do? It's supposed to flip it over the y. So there's just a confirmation real quick. Flipping it over the y. Now, what's a negative times a negative? Positive. So if I did negative square root of negative x, I should get back. Should I? No. I should get yes, you're correct. I should get a reflection on x, and I should get a reflection on y, correct? Because I have both going on. So you can see it here, and there it is. So there's all four of them, and you can see the pattern for each one of those. We can compress, we can shrink any one of those. But I wanted to talk about those values. If we were talking about the root function, the parent function or the main one would be if, I don't know if I want to do negative. Let's just do a x minus h plus k. So we follow the same process just about every single time, right? If we have absolute value, it would be the same idea. So I don't want you to think that any of that goes away. Even when we did the logarithms, you guys remember the logarithm ones? If I had y equals log, let's go with what, 5? Let's just go base x. Okay, how can I change how fast it goes up or stretch compression? There would be an a value up front. And then I could shift this right as well, minus h. So all the components are still there. And if I wanted to move, sorry, that's not an h at all. I can have h, and then if I wanted to shift the whole thing up or down, I can go with k. So nothing is changing. And we're still good on ah and k? Give me a thumbs up if you're good with ah and k and their function. Good, let's move on then. So here's what we have now. Here is our first graph. You've already seen it. It is the graph of sine. The domain goes from negative infinity to positive infinity. The reason for that is, how long can I go around that circle and graph all those critical points?
Infinity.
Forever, right? And how far can I go backwards and graph all those points? Infinity. So my domain ends up being from negative infinity to positive infinity. As a reminder, this is an odd function. My range goes from -1 to 1. My period for this is 0 to 2 pi. And just remember that a period is simply when it repeats itself, right? After that amount of time, the function just looks exactly the same. So we're just repeating. This is sine. What's up?
What's trigonometry? Is it just like geometry?
No. Well,
I'm confused on what trigonometry is teaching.
geometry is a lot of
Shapes.
shapes and stuff, and has a little bit of trig in it. But trigonometry, try 3 angles. And this is kind of what we started off with, right? We started off with the 30, 60, 90, 45, 45, 90. And then we looked at the sine, cosine of all those. But all we did was start to expand on that, the ideas. And we're still working with sine, cosine, tangent. But we're just looking at it differently. So it's all going to be about sine, cosine, tangent. And I don't want to say that's going to be all right triangles. Because eventually those ideas will also expand to talk about non-right triangles. So the ideas grow and grow and grow. But that's what we start off with. Period. I feel like I need a cough drop. Are we okay here? Anybody need any more of this information? All right, cool beans. Let's move on. Alrighty. Why didn't they give us everything else? Okay. Okay, let me add a slide real quick. So let's start with something simple here. Y is equal to sine x. I have a function. At the very front, I'm going to have a. Do you guys remember what a used to do? The stretch compression. Same idea. It does create our stretch compression, but we're not going to call it stretch compression. This is actually going to have a name. Yes, it's kind of nice that it starts with a, right? This is called the amplitude. Amplitude.
I've actually heard that before, but I've never. I feel like I know what it means, but I just can't get to it. I had cards in my class. Well. Thank you so much. What does it pick you up? It doesn't. Your socks are weird. Thank you. Oh my god, your socks are so adorable.
Is it pleasant?
To make a high sock version. You can actually see.
I'm sorry, you have to smell that. Do you need some like Febreze or something?
Wait, did someone fart? No, I was just trying to make a joke. Somebody just say,
I feel bad. I feel like I should give you one of those.
Yes.
And now you're
So what's going on?
What's going on?
Hey, yeah. How much about you?
ew.
I forgot to say.
I had to give him one. He's like trying hard.
He was like, do you guys smell that?
That's a pup dog over there.
What's up, dog?
What's going on?
Okay. You guys go with that?
What is
So amplitude, let's go ahead and do this real quick. So let me kind of sketch my sine function. Okay, look like that a little bit. Amplitude tells me how far up and down it goes. Okay, so the absolute value of that will actually tell you the distance you're going to go up and the distance you're going to go down. So whenever you see that, that's what we're talking about. So if this was a 2 up front, then that means that my sine function would simply get stretched by a unit of per 2. It would go up that much higher and that much lower.
So that's always going to be an absolute value though?
Well, the distance is absolute. So whenever I see a 2 there,
You automatically know.
you should know that it goes up 2, down 2. Okay? So when they ask you for the amplitude, so I should give you a better definition here. So amplitude is the absolute value of A. Now, I have to say it this way because, remember, if A is negative, it just simply means a reflection. That doesn't mean that you go -2 and -2, right? Because the distance will still be positive. So when they ask you for an amplitude, it's simply how far up and down you're going. Therefore, it's the absolute value of A. Because sometimes you will get a negative number there. Okay, and here's what I mean, if you don't understand that. Sine goes up, and it looks like this, correct? So this is sine x, but if I had negative sine x, then my function, instead of starting by going up, it will start by going down. It will look like that. So this still goes up 1, down 1, so should this one. The amplitude is simply 1 for both of them. So we say that the amplitude is the absolute value of A. Did I erase it? We just say it's the absolute value of A. Okay?
Did you turn off the inferness?
Good.
Like the
Time out. I need 2 questions.
No.
There's one here. Somebody else needs to ask me another question. Go ahead.
Oh, I can answer right now.
Ask me right now.
Oh, okay. For the side with the Christmas color.
For this one?
Yeah. So if it was negative absolute A, would it, or absolute 2, would it be like that but then reflected?
No. No, I did that and I shouldn't have. Your function will always read like this, or it might be a -2. When they ask you for amplitude, then you need to know it's the absolute value of that number. So if I did give you this function, I said, hey, what's the amplitude here? You would say 2. You would not say -2. That'd be wrong. Negative is just information for me, telling me that this thing is flipped, or reciprocated, or reflected on the x. Okay? That answer your question? One more question. Anybody? That's not a question. Mills, ask me a question.
Like, what is this? Like, why? Like, I get if you're trying to find angles, or if you're trying, I just don't, like, what? Like,
Okay, can,
curves on.
yeah, we're graphing curves.
Like, why? Like,
There will be a lot of stuff that goes on where you graph curves, okay? Is anybody going to use these in their jobs for real in their careers? Probably not, okay? So,
What the heck?
hold on, you're the one that took my course, so
No.
that was bad. That was a bad shot. Come here. So, um,
Graph sign with the table.
so there's a lot of stuff that behaves circular, or how do I say this? Has these patterns that are repetitive in nature, okay? If you do nursing, then, or if you become a doctor, you guys have seen the heart prints, okay? The way your heart goes in cycles, okay? So that's what you're looking at there too. When we're talking about, well, you probably won't, but you know how to read that. you have to learn how to read that, and you will have to do some of that. If you're working with sound,
Its own thing.
and there's some pretty cool stuff going on with sound right now. Have you guys seen what's going on with sound?
No.
Have you guys seen that they're actually starting
And
to
like
pick
microwaves.
No, but I've heard.
microwaves? With sound right now, they're actually doing a visual thing so I can actually see what's going on with sound. They're actually picking up objects with sound waves now. And what they're doing with that is that they're creating frequencies that might produce a sine wave, and while the other might produce a cosine wave. And what they're doing is they're trapping objects between the two waves, and then they're moving it around and manipulating it. Yeah, which is really, really cool. So yeah, this might not be the most interesting thing. Will a lot of people use it? Probably not. But it's part of the course that's supposed to make you a bit more thoughtful. Okay? And it's just another one of the functions that we're using. So we've done cubes, we've done logarithm, we've done all kinds of them. This is just another one for your arsenal. What's up?
So this section of the chapter, like 4.5.
This whole semester.
No, it's part of my question.
Okay.
It's like 4.5. That's all gonna be like shifting then.
Mhm. That's all it is.
What is the
Math.
When, what day?
I don't know. I'm gonna spring it up on you one day.
Next Tuesday, is that
No, this week.
this week?
Yeah.
No.
Have you seen a Bunsen? Not a Bunsen tube. A Rubin tube.
Oh, probably.
Okay. Have you seen a Bunsen burner?
Yes.
Everyone know what a Bunsen burner is? A Rubin tube is a tube that has many Bunsen burners in it, so there's many, many flames. I have to show you this.
Wait, have you seen they can put out fires with sound?
I don't know if they're there yet.
No, they can. Like with like bass, if they like put it low enough.
So here, check this out. So, is my sound on? Why before I know hear sound? Who dares touch my stuff? No, it was on.
Just EDM.
Yeah, it actually does have some EDM on there. Here we go. So these are Bunsen burners. So it has a bunch of gas through there, and they just light it. And here's what they've. Let's see here.
Sign of X.
One end is blocked off, the other end is a piece of latex.
Oh, that's why.
It's gonna be the
Okay.
last one.
I know it's gonna sound amazing.
The bass.
No, because well, I already gave away a lot of it. So
In the Cymatics music video is the Rubens tube.
So the Rubens tube is my personal favorite experiment. Okay, just tell us how it works.
Okay, so we've got our propane, it's going to flow in here. There's a line of holes here.
a lot of this is really new stuff that they're doing with it. But
One end is blocked off, the other end has a piece of latex on it. And we're going to play sound very loudly onto the latex. It's going to form standing waves of gas, and it's going to come out the holes at different heights depending on the frequency of the waves. Playing?
There you go.
That's good, that's good.
That's a nice, safe. Okay.
so there's your Bunsen burners.
It looks like a graphic equalizer, just made out of fire, which is really visually exciting. It looks like a Gothic organ or something like that. So a lot of the testing with the Rubens tube had to do with finding out what waveforms form the most pleasant looking standing waves, and then how we could use that to create a piece of music. To complicate things, I wanted to shoot in slow motion, which meant that we would have to take the notes that we'd figured out and play them 4 times as fast to keep them in sync with the music. And just to make it look even cooler, we shot it at higher volume so that more fire was coming out.
So later in the video, we wanted to hit the Rubens tube with the Tesla coil. We talked it over with the Tesla coil engineers, and they assured us that as long as the Rubens tube was already lit, it would be okay, even though it looks like something that in the movies you fire lightning at a gas tank and it explodes and kills everybody.
We were pretty nervous about turning that thing on, but true to Nigel's abilities, it was built perfectly and never a single problem with the Rubens tube.
Just dance that. Um,
No,
check out. So here's a Rubik's Cube like extreme. They created a a pyro square. I don't know what they called it. But that's the idea.
Yeah, go for it.
Multiplied out.
Whoa!
Now you may have seen a Rubens tube before. That's basically a pipe with a bunch of holes in it, and you pump in a flammable gas and light it on fire. So you basically create a row of Bunsen burners.
They make like cool patterns with sand.
Yeah, that's a different one. They actually put the frequencies onto a plate.
Yeah.
There's a whole study on. Oh, this is really cool. Have I shown you guys this video?
No, you haven't.
Okay, so that's it. So this is controlling the water with flow. Now this is what's really cool about this. Towards the end, so they're pumping sound waves in there. This is it kind of does look like one. So here's your disclaimer. None of this is altered in any way. Like it's not video edited. This is all just live. So here's your water flow. They pump a sine wave in there.
That's how I feel.
Look at those points. Look at those.
The moment you hit your arm just right,
Like this.
your entire nervous system when you hit your arm.
When I misbehave, that's how I know.
So right now what he's doing, he's playing with the amplitude, so he's stretching that out. Yeah, because it's vibrating. It's hooked up to a speaker, the speaker has to produce the sound, and then it makes the hose jiggle.
No, I've been doing that in the shower. Like, it's really not that impressive.
Okay, so here's your forward. Looks like the water's falling in slow motion. Here's what I want to show you guys. You guys ready? So, you guys remember how we went one direction in the circle? We could also go in the negative direction? Right?
No.
Here's a negative effect. Check out the water. Where's the water going?
How do you
It's going down.
It's still falling down.
How do they do that? Like, how does it vibrate like that? It's not a. There's no such
It's a
thing as
negative frequency.
vibration.
It's in reverse. So instead of being a positive 25 hertz, this way, it's shifted the other direction. But it's still falling.
You know what's going to be our next engineering project, right? Oh, no. Oh, yeah. We're both failed. Yeah.
Check out the designers. I'm gonna email everybody and like set up a conference. Wait, before you put it out,
That my ring is right there.
that's weird. We're talking about telling Billy that I do. Billy, yeah. Across for her next music video. I'm trying to fix my hat. So we're not getting paid. So we're not getting paid.
I become Lily's manager.
I become her. You can't manage yourself. Hey, don't call me. You called me out like that yesterday too. Don't do it again.
Or what? It was easier. Yes.
I might get promoted today.
Really?
Yeah, I might. I'm not sure.
You
I hope so.
You will.
What were you at today? Did you ask the students questions? Because our observer asked us questions.
Yeah, some of them. Take your earbuds out, put your cell phones away, close your laptops. I need you to do this bell work here. Where's it at?